This chapter aims to build a reactive version of our farm harvest management application, wherein each of its components processes transactions and operates in an asynchronous manner, applying the reactive streams specification. This chapter will start from building a reactive web application, starting from its data persistency layer up to the view resolver, and then the discussions will be channeled to applying the functional web framework, using the new reactive Spring Data R2 DBC for implementing reactive JDBC transactions, building reactive RESTful services and SSE resources, and of course, securing our new reactive application. This chapter will also update us on the platform's Kotlin support and its new Spring Data More Reactive module. Let us begin this chapter by implementing the reactive core components of our web application. Spring Boot 2.2 actively supports the reactive stream specification, which enables a component to push its free-flowing and unlimited resources or elements to another through its Spring Webflow Starter module. Let us now implement the core components of our web application, now using the Webflow Starter module. To build a fully reactive Spring Boot 2.2 web application, we first need to include in its Gradle build the Spring Webflow Starter module and avoid Spring Web, Spring Tomcat Runtime, or any MVC-based Spring Boot modules that may override any configurations of our Webflux module, making it ineffective. For the meantime, we will be utilizing the reactive version of our Spring Data MongoDB, since there is no reactive counterpart for our Spring Data JPA, meaning the Spring Data JPA cannot provide us reactive query methods. Also, do not forget to include the flapdoodle embed for our Mongo testing. And to render our reactive streams, we need to include also the Thymeleaf starter module. Assuming that we have installed and configured already our MongoDB server and set up the necessary Spring Boot properties in the project's application.properties file, we can now create the necessary repository classes for the profile and harvest transactions through the reactive CRUD repository generic interface from our reactive Spring Data MongoDB module. A reactive CRUD repository can auto-generate or provide us a custom query method that can accept a publisher stream object, and some of them can generate a publisher stream which can be consumed by a subscriber stream object. A publisher stream object is the one that pushes these free-flowing and unlimited elements to a component, while a subscriber is the one that consumes them. In order for a publisher and subscriber to communicate, they need a subscription which implements some sort of a back pressure mechanism which involves several threaded operators to manage and control the flow of elements. Now, Spring Webflux has two specific publishers, namely the Mono and the Flux. The Mono contains and generates only one element, while Flux can contain and control several elements in one stream. To utilize these reactive query methods, we can build a reactive service layer to process them, or we can just directly access them in a web controller, such as this user's controller here, to process a Mono or Flux streams of profile records. In this web request here, a flux of profile will be retrieved from a publisher stream generated by this find_all reactive query method. Now, I used two back pressure methods in here to process the element retrieval. The first one here is the distinct operator, which uses another thread to ensure that all the elements are unique. And the other one, this delay elements here, that uses another thread to impose a waiting time of 10,500 milliseconds for the web request to wait for the completion of the element retrieval. Now, there is no assurance that all the profile records will be retrieved given this time duration. Whatever number of records are retrieved by the back pressure operators, The generated flux of profile will be transported directly to a ThymeLeaf template engine for rendition. Now, the setup and configuration of our ThymeLeaf template engine will be different since it will be utilizing its ThymeLeaf Reactive View Resolver and Spring WebFlux template engine. The setup is quite similar to an MVC-based application except for the absence of the set content type property since it is not supported anymore by the ThymeLeaf Reactive View Resolver. The reactive ThymeLeaf View Resolver can now render directly a mono or flux streams of data if and only if the web application is reactive, utilizing 100% the Spring WebFlux Starter module. And as much as possible, it uses a non-servlet Netty server in deploying and running its own components. After deploying our project to an embedded Netty server, we can now run our fully reactive web prototype, but we need to wait for 10,500 milliseconds before ThymeLeaf renders the stream of profile records. We can include also other reactive stream-related libraries such as RxJava if there is a need for them to compose some reactive streams. We have presented to you how to build a 100% reactive web application using the Spring WebFlux Starter module.